Hello friends, welcome back to Graph Theory lecture series. This is our lecture number 7, and in this lecture we are going to study what are matrices of graphs. So basically there are two types of matrices of graph. There one is adjacency matrix and another is incident matrix. Okay, so let's see what are the matrices of graphs. So first thing we will see is adjacency matrix. Okay, so let G equal to V, E and phi be a graph means this graph can be any graph like a simple graph or graph with multiple edges or loops. Okay, so G be a graph, the adjacency matrix we will denote it by A of G is the set Aij. Aij is the position in the matrix, ith row and jth column is what Aij entry is what number of edges between Vi and Vj. Okay, so Aij denotes the number of edges between Vi and Vj. So let's see an example. Okay, so let's take this to be our graph G, A, B and C, or you can call it as V1, V2 or V3. Okay, so what will be adjacency matrix? This will be, we will write V1, V2 and V3 here, and for the columns also V1, V2 and V3. Now this first box is A11, right? This position is A11. So A11 means the number of edges between V1 and V1. So there are no edges in V1 and V1. Therefore this entry will be just 0. Okay, this entry is A22, right? So what will be there in A22? That means number of edges with between V2 and V2, right? So how many edges are there? There are 0 edges. Now this entry is A12, first row, second column, right? That means the number of edges in between V1 and V2. So how many edges are there in between V1 and V2? There is only one edge, right? So this entry will be 1. Now similarly, what will be the entry here? The number of edges between V1 and V3 is just 0. Number of edges between V2 and V1 is 1. Also number of edges between V2 and V3 is 1. Here number of edges between V3 and V1 is 0. Between V3 and V2 is 1, and between V3 and V3 is 0. So this will be adjacency matrix of this graph G. Okay, so this is the adjacency matrix of this graph G. So now you know how to make an adjacency matrix. So let me give you another example in which we have some multiple edges or something. Okay, let this be a graph G, and these are vertices V1, V2, V3 and V4, and this is graph G. What will be adjacency matrix of graph G? This is our, so this entry is our A11. So what will be there in A11? That means how many edges are there between V1 and V1? There are 0 edges, right? V2, V3 and V4. Okay, so how many edges are between V1 and V2? There are two edges, right? How many edges are between V1 and V3? There are zero edges, and there is one edge between V1 and V4. How many edges are there in between V2 and V1? There are two edges. So similarly, there are zero edges in between V2 and V2, V2 and V3. There is only one edge. Between V2 and V4, there is no edge. Between V3 and V1, we have zero edges. Between V3 and V2, we have one edge. Between V3 and V3, we don't have any edge. And in between V3 and V4, we have only one edge. Now see, in between V4 and V1, we have only one edge, and in between V4 and V2, we don't have any edge. In between V4 and V3, we just only have one edge, and with V4 and V4, we have two edges. Remember, loop always counted twice. This is one edge E1 and this is another edge E2. Okay. So this is our adjacency matrix for this graph G. Clear? Now let's see second type of matrix, that is incident matrix. Okay, so what is incident matrix? We will denote it by M of G. So M of G is just set of Aij such that this will contain just entry 1 and 0. Okay, when will the entry be 1? 1 if Vi is endpoint of Ej and 0 otherwise. Okay, so I will give you an example for this. Example is, just take this graph, simple graph V1, V2, V3, E1, E2. Okay, so now here we have V1, V2, V3 and E1, E2. Okay, so how are you defining the incidence matrix? We are defining that the entry will be 1 if Vi is endpoint of Ej. So here we have A11, that means V1 and E1. So V1 is endpoint of E1. Is this true? Yes, V1 is endpoint of E1. So this entry will be 1. Another thing is V1 and E2. So V1 is not an endpoint of E2. Therefore, this entry will be 0. Now V2 is endpoint of edge E1. Therefore, this entry will be 1. And V2 is also an endpoint of E2. Therefore, this entry will be 1. Another thing is V3 is endpoint of E1. That is no. And V3 is endpoint of E2. It is yes. So this is our incident matrix of graph G. So observe a thing, that this adjacency matrix is the symmetric matrix. Right? You can observe from here that this will be symmetric matrix. And why it will be symmetric matrix? Because if there is an edge between V1 and V2, then there is an edge between V2 and V1 also, right? If V1, Vij have edge or it does not have edge, then Vji will also follow same, right? Therefore, the entries in Vij and the Vji or Aij and Aji will be same. So the adjacency matrix is always an symmetric matrix, but that is not the case in the incident matrix. Okay, so hope you understand what is the incident matrix and what are the adjacency matrix and how do we find them. Thank you for watching.